take an hour and do a very quick and short summary of the confined space entry standard as it relates to both entry and rescue. Can I have a show of hands? Who is a firefighter or a rescuer currently in their community? Very interesting, very unique setting that you have here in this state. Approximately anywhere from 30 to 60% of your people that work in water production, wastewater treatment, are also part of the emergency response community. That's a great asset for you. That's a great resource. It's very important that you recognize that all of your personnel that serve as an attendant are actually part of the rescue solution, and we'll talk about that. If I'm an attendant and we have a permit required confined space, what's your first name?
George.
George. George is my attendant, and I'm an entrant in a permit required vertical confined space. Traditionally, what will I have on me as the entrant? A harness. I'll have a harness attached to what? A winch or mechanical advantage, correct? And if I'm an old guy, I'm 57 years old, if I have a medical emergency or some problem, my attendant, George, is going to do what? He's going to do non-entry, don't go in, rescue, correct? He's simply going to retrieve me and bring me up. He's going to do a couple of other things. He's going to call 911. He's going to call for assistance. And that could be outside emergency responders. It could also be some of the other people working in the area because he's going to need some help. And in turn, he's going to ventilate that space if it's a long haul, because ventilation will do what? It'll buy time. It'll buy time. One of the challenges for you as a collective group is that ventilator traditionally is back in the shop. Yes? You've just taken away 1/3 of your rescue tools, so you've limited your toolbox. So we're going to discuss not only rescue, but we're going to discuss entry. First of all, the confined space entry standard is very unique. It's unique because it not only addresses specific actions on the part of the space owner, but it also addresses some other people. Trenching and excavation. Who's an excavator or trencher? Who does any of that work? Okay. Whether you're a rescuer, whether you're a contractor, whether you're a public sector worker, there is one set of rules. The trenching and excavation standard. It is what it is. When you talk confined space entry, you have 3 different components to that standard. They talk about you as a collective group, how you and your employees enter those spaces. It also says, and we're going to touch on this today, if George, as the wastewater supervisor, hires us as contractors, by this standard, he must share specific information. He must tell us the classification of the space, he must tell us the hazards of the space, and he must also tell us the history of the space. And when we're done, George should ask for our completed permit, and then that becomes the further history of that space. Does that make sense? First name, Herb. So Herb, if Herb happens to go into that confined space and has a medical emergency, that becomes part of the information that George has to share with the next contractor. Make sense? In addition, this standard is very specific. It says regarding rescue, it's not the fire department's responsibility to know what's happening in that confined space. It's the owner of the space's responsibility. And you actually have to develop a rescue plan. It could be as simple as we're always going to use a mechanical advantage system so that attendant can always do don't go in rescue. But most of the locations that you have clarifying basin, aeration basins, they have horizontal entries that you may not be able to stand on the outside, pull as strong and mighty as you can, God bless you, to get that person out. I want you to remember this when you go back I want you to look at your confined spaces with a fresh set of eyes. I want you to recognize that the confined space standard is very simplistic. It's a 4-step process. And the very first component you've all done a pretty darn good job of is an area of confined space. You've established it is or it isn't. If it meets the 3 criteria for a confined space, limited means of entry, not designed for continuous human occupancy, wouldn't want to have lunch or dinner in it, and you can bodily enter, it is a confined space. So a chlorine room with a full-size door is not a confined space. It happens to be a room with a potentially hazardous chemical from a respiratory standpoint. Make sense? Not the number of doors at all. It's the size of the doors. The second component, and this is where many of your agencies really struggle, and that is the second step is classifying. We're going to put it into a cubbyhole. We're going to make it non-permit required, alternate entry, or full permit required. One of those 3 classifications. The third step is, if we call it a duck, we treat it like a duck. If we call it a goose, we treat it like a goose. If we classify it non-permit required, we can go in just as we're dressed. By the way, now, let me walk through the process here. Is your attic or crawl space a confined space? Who says yes? Okay, all you people that say yes, you're right. Now, don't throw anything at me yet. We now have to go to the next step in that process. We have to classify it. And I would say, traditionally, your attic or crawl space is a non-permit required confined space. Would you agree? Therefore, we can enter. Randy, you and I can go in. We're doing a little plumbing work in the crawl space. We're going to do a little work in there. We can go dressed as we are. Heaven forbid you make the mistake of giving me the Sawzall. I'm really good at breaking things. I was a truck company officer for a long time. Very small brain, very good with tools. And Randy, we're cutting that pipe and I happen to drop that pipe right on your leg and I break your leg. Now we call 911. The challenge here is in non-permit required entry, it's easy, but rescue is going to be very difficult because my emergency responders come and now, can they pull on the lifeline? No, because he doesn't have it. So they have to go in. Can they pull on his harness? No, he doesn't have it. So they pull on Randy's shirt. One of 2 things happen. He either completely comes off or tears. Now we have Randy stripped naked from the waist up in the crawl space with a broken leg. See the challenge? Entry is easiest, but rescue is most difficult. Okay? So we're going to kind of walk through that process. Does anyone have any questions? It's really important. Any space that you deal with that you're not clear or sure of. Let's take an elevated water storage, the golf ball with the tee. I tell you that when you open that door to go into the middle, that is a confined space. Are we okay with that? When we go where the water is stored, that is a confined space. Yes? When we go into a dry well or a wet well on a lift station, confined space. Storm, sanitary, independent of depth, confined space. So far, so good. Clarifying an aeration basin. Who are my wastewater people? You know, it's interesting. Your state has done a really good job of getting clean water and dirty water to work together. Because in most states, the clean water people, they have a lot of focus. People are visiting their plant all the time. They're helping them out. But the dirty water people, wastewater people, everyone kind of wants to stay away. So what happens there is, in most states, there's a huge disparity between the level of safety and focus on the part of clean water and wastewater. You've done a really good job of marrying those 2 groups. This is a good example. Clarifying and aeration basins. Confined space? Yes. Yes. Influent. Bar screen. Bar screens are real. By the way, when we get into, is it a confined space, wastewater violates some of the simple rules. If we have a door that goes down to a set of stairs into a basement, for almost every other occupancy or every other occupation, it is not a confined space. Would everyone agree? Is your basement a confined space? No, because it's designed for occupancy. Traditionally, a full-size door and stairs say it's not a confined space. But bar screen rooms, which traditionally have a full-size door and stairs going down into a big open part of the sewer, yes? Is that a confined space? It breaks the rule of thumb, and the answer is yes. Simply because there's no difference between that big bar screen room basement and a sanitary sewer outside. Would you agree? So when you look, wastewater people, when you look at your confined spaces, step back a little bit, and you may have to reevaluate that. I got a big old plow horse in the field. I want that plow horse looking right or left. So I put blinders on that plow horse. All I'm doing is focus on this path right here. When OSHA has you classify confined spaces, that's exactly what they've done. They put on blinders. They've limited your focus. Tell me, what are one of the considerations for classifying a confined space? There are three, by the way.
Access.
Good. Well, access is one of the criteria to designate whether it's a, George, good answer, whether it's a confined space. But what's going to put it into one of these cubby holes? Good, hazard. And I'm going to be even tighter than that. 3 hazards and only 3. A reasonable potential for poor air quality. Reasonable potential for poor air quality. Lockout, tagout, or isolation. If I have to go into a clarifying basin, we better shut off flow, correct? Yes? If I have to go into where the water is stored on that elevated water storage, I better shut off flow, yes? And the third component is engulfment. A potential to be engulfed or surrounded. Make sense? As we look at this, and we look left to right, non-permit required has no reasonable potential for poor air quality. This building here has large ductwork. If I have a door on my ductwork, is that a confined space? Yes. Now when I go in there, I better turn off the fan, correct? Because getting chewed up by the fan, yes? So I have an isolation issue. But I propose to you that we do not have a reasonable potential for poor air quality, correct? Would you agree? Therefore, it is a non-permit required confined space. Randy and I can go into the crawl space or the HVAC ductwork in a non-permit required manner, just like we're dressed, correct? However, firefighters in the area say, whoa, wait a second, we would like you guys to always have a harness on because we want to be able to grab you and haul you out. Can they do that? Can they do more than the standard dictates? Yes. That's where George says, my rescue plan is for Randy and Mike, every time you go into any confined space, you'll always have a harness on. You can have it loose, you can have it tight. Now we as emergency responders can take a 22-foot piece of 1-inch tubular webbing and we can do some real sexy modified diaper hasting harness and a bow tie and a shoelace, and we can do that and drag them. But we have to have that skills, and we also have to have that equipment there. As we move to permit required is actually divided into 2 space describers. The first one is alternate entry. It came from the telecommunication industry. When you see Verizon, AT&T, US West, or US Quest, anyone in the area that's going into a fiber optic vault, 67. What do you see? What do you see? Good. First of all, alternate entry, I call a level 1 because it has one hazard. The only hazard that it has is a reasonable potential for poor air quality. So if you have a dry well, a water valve vault, that the only hazard there is a reasonable potential for poor air quality. Make sense? And we are going to follow, get the next one. We are going to follow, yeah, I got it. Sorry, my fault. I lost this, I lost. Does this make sense? Alternate entry says, if we call it alternate entry, if we classify our confined space, alternate entry, the next step in the process is we have to follow the alternate entry rules of entry, which are as follows. Fill out a permit, barricade the opening, because only one person is going in, so when I'm walking my dog and my entrant is there, I can fall right in, so we have to warn them. Cones, another person, test air quality, monitor air quality, and continuous ventilation. Notice there's no attendant. Notice there's no harness. Notice there's no mechanical advantage system. So by law, if you classify one of your spaces as alternate entry, a valve vault, dry well, you can go in one person following some rules. You good with that? So classification is going to be important. Very, very important. When we get into permit required, we have 2 or more hazards. That is, we have flow into the space, clarifying, aeration basin, bar screening rooms, storm, sanitary, reasonable potential for poor air quality. We either have a chance for engulfment or we have a chance for a lockout tagout failure. So those 2 or 3 hazards, call it permit required. If it's permit required, we must do 8 steps if it's vertical and 7 steps if it's horizontal. So what we're going to be doing is these 8 steps. Who currently uses a permit process, a permit? Here's my challenge for you. If you're not using a permit and you're entering alternate entry or permit required confined spaces, as a manager, you're putting your organization and yourself totally at risk. Send Glenda or I an email and I will send you a permit. Use it. Because if you injure one of your people, you are really in a tough position, because the cornerstone of the permit required confined space standard is the use of a permit. If you don't use the permit, it says you're either not interested in your workers' well-being, or you're not educated enough to be interested in your workers' well-being. That's a tough defense, yes? Because it's simply a piece of paper. It's a checklist. It's not asking permission. It's a checklist. That checklist, in an emergency, speaks to the emergency responders, because it explains what you, the expert, did in the space and found in the space. I started this work in the early 90s, and the DuPage Water Commission, they are a Collier County of Chicago. They were responsible for bringing Lake Michigan water out to a very wealthy county, DuPage. And they lost 2 workers, a 19-year-old and a 36-year-old, in a water valve vault. 6 foot deep, 6 by 4. They had gone into 600 of those that previous year. No training, no equipment. They just open the cover, down they go, do their job. On that day, the 19-year-old went down the ladder. Halfway down, he became overcome, fell, started to drown in a pool of water in the corner of that water valve vault. What did the 36-year-old do? He went down after him. Halfway down the ladder, he became overcome, fell, broke his neck, and died. Fire department responded. They couldn't fit into that 20 or 22-inch manhole with the breathing apparatus, so they decided they were going to tie a rope to the first one, to the second one, and the third one. As the third one's going in, he recognizes that the other two are becoming unconscious. He pulls out the second rescuer. After about 5 minutes of exposure to ambient air, he becomes conscious. The two of them now pull out the totally unconscious first rescuer. These two guys go to the hospital. They have no permanent disability. They were this close to losing 5 people. And why? What caused poor air quality? Yes, oxygen deficiency caused by what? Rust. Yes, absolutely. You see a rusty, nasty-looking space, it probably is oxygen deficient. The only way you're going to tell is to assign one of your people to be the canary. Wear the canary suit today. Down you go. At least you know your job. Or use an atmospheric monitor. Now, the beauty of atmospheric monitors, my company does confined space standby rescue. We've done it for about 15 years now. I've seen a whole change in atmospheric monitors. They've gone from thousands of dollars to $400 and $500 today. You can get a beautiful, small, durable 4-gas monitor for $500. It's amazing. Turn it on. When it's bad, it says, I'm bad. And you give it to somebody that fixes it. I mean, it's a beautiful thing. So, number one, every one of you needs to recognize you need a permit. Go to 13 if you will, Gene. Perfect. I want to make sure that we have perfect clarity before we get into some of the entrant components, but are there any spaces, and I'm just going to touch on a few here, are there any spaces that are outside of these photos that you have a question on? A, whether it's a confined space, and then B, what its classification is. Independent of depth, storm or sanitary, permit required. Water valve vault, alternate entry. Now, some agencies don't like alternate entry. Abbott Labs, as an example, it doesn't exist in their world. They force everything to the permit required, simply because they want my attendant George to be able to retrieve me from the outside, rather than go in and have to set that up. A lift station, dry well, alternate entry, wet well, full permit required. Many dry wells have built-in ventilation. Open the lid, the light goes on, the ventilator goes on. That does not remove the hazard of a reasonable potential for poor air quality, because you really don't have a good handle on whether that squirrel cage ventilator is actually operating and operating correctly. Traditionally, they only move, God bless you, they only move air from one location, top or bottom of the space. This is a pool surge tank. Very interesting. When the pool is empty and the surge tank is empty, it's an alternate entry space. When the pool is full, now you better isolate, and that second component, it turns into a permit required confined space. Are these confined spaces? Yes. Now, how you enter those spaces will determine how we classify those spaces. I give you, if I go into a deep, heavy aeration tank, it's got a lot of sludge in it, would you all agree there's a reasonable potential for poor air quality? Yes? Perfect. So permit required. Having said that, my guys say, we don't want to enter that permit required, so what we're going to do is stand on the top. We're going to take a heavy hose, a 2.5-inch hose, and we're going to remove the lion's share of that sludge. So it's fairly clean, correct? Yes? Now, we don't have a big buildup of sludge. Do we have a reasonable potential for poor air quality? Probably not. Probably not. Now, you can always go stronger and say yes. Who says yes? Okay, I'm good with that. Normally, I'm fighting people the other way. They're going, no, you're the first one. You know that. But if you establish a practice where you aggressively clean that prior to entry, you may potentially, depending on the configuration of the space and the material inside, you may have removed that hazard. So you have the ability to manage those hazards. You must do a lockout tagout. Once you do a lockout tagout, you have not eliminated that hazard because valves fail on a regular basis. You've effectively dealt with it. In the electrical generation industry, they have their own separate standard. They actually declassify their boilers because they're allowed, once they do a lockout tagout, they say that that hazard has been removed. In your world, that does not exist. Does not exist. These are Keebler ovens. 50 doors on the side of an oven. Is access into that oven a confined space? Yes. We have lockout tagout because it's important, and we have the conveyor to stop it. We also have, God bless you, natural gas. Therefore, we have a reasonable potential for carbon monoxide. Therefore, it is a permit required confined space. Horizontal, 7 steps. And we'll talk about those in a minute. Manwood. That, believe it or not, that pressure vessel was made for a welder to enter to do repairs. They have welders that go into 16 and 18-inch spaces all the time. You are no smaller than your hips. You can swim, you can move in, but your hips they are what they are. So a permit required confined space. A chlorine room is not a confined space. Would everyone agree? Yes? Perfect. A trench is not a confined space. It's confining or restricting, but the only overflow for that, or rollover between those two, is at 4 feet in a trench, you have a reasonable potential for poor air quality. You must test air quality. If you find poor air quality, you must ventilate. Just same equipment that you would use for a confined space. But if you go into a trench, no one would ever say you need a harness, you need to be attached to a mechanical van system. So permit required. Every time you classify something as permit required, you're going to need, whether it's alternate entry or permit required, to utilize the use of an entry supervisor. OSHA defines the role of the attendant, the role of the entrant, and says that the person in charge, extra hat, could be a third person, or just a hat that George and I are wearing and we can pass it. They are responsible, and they are responsible for completing the permit. A signature on the permit by the entry supervisor is one of the 15 mandatory components. So George is the entry supervisor, he signs it. If we get into a problem, you guys as rescuers, you need to ask the question, who is the entry supervisor? Bad news if I'm the entry supervisor and I'm dead in space. That's a bad way to start. Okay? But I want you to recognize, all of you from this point forward, please go online, call us, do whatever, go to your local vendor, whatever it takes, get a permit. Get a permit. Any questions? Anyone want to arm wrestle with me on that? Permit, once you complete it, should go back to the boss, and that boss should keep it for at least 1 year. OSHA says every year you must formally evaluate the permit process. That's the one we use. Pretty simple and clean. I have 45 firefighters and policemen that work for me, and we try to use the KISS principle all the time. It's very important. Atmospheric monitoring. Who has a 4-gas atmospheric monitor? Good, very good. Today the focus is not only making them smaller and more user-friendly, but making calibration much easier. Today, companies like MSA, they have a device called Galaxy. You simply put the monitor in, you close the door on it, you turn the gas on, and it chimes when it's done, just like a microwave. You turn the gas off, open the little hatch, and it's ready to go. It can't get any easier than that. So 4-gas atmospheric monitors. If you're lowering them into a space, they must have latching or peak hold. It grabs that worst case readings. If you're drawing it up, the rule of thumb is for every 2 feet of tubing, you add 1 extra second. So if I had 10 seconds for the monitor, and I had 50 feet of tubing, I had 25 seconds, so approximately 35 seconds at every level. And if we're testing vertically, we should test 4-foot increments. Again, I try to keep it really easy for all our people. We have a monitor lowering rope. It's got a knot every 4 feet. So it's really simple. Go to the knot, record it, go to the knot, record it. Horizontally, if I'm testing, I used to be a travel hockey coach and I have a lot of broken hockey stick shafts because of that. And if this is my point of entry right here, and I have my monitor, I can only test right here. So we actually take that tubing and we use a little duct tape, because duct tape fixes everything. Put it on the end of that hockey stick, and standing right here, I can measure 4 feet in, up, and down. So simple little things like that really allow us to be safer as we're entering those spaces. We're testing for 4 gases: oxygen, both enrichment and deficiency, carbon monoxide, odorless, tasteless, and colorless. The monitors respond to what they call the PEL, the 8-hour exposure that we will start to get sick when we reach that number. As an example, that's 35 parts per million for carbon monoxide. What is a part per million? Can anyone give me a visual indicator of a part per million? Who in this room has had a shot of whiskey in their life? or tequila. Okay, I want you to visualize, in a room about half this size, a shot glass of carbon monoxide or hydrogen sulfide is 1 part per million. So if we had 35 parts per million, visualize 35 shot glasses of carbon monoxide when we'll get sick for 8 hours exposure. Ideal H, immediately dangerous to life and health, kill you right now. 1,200 shots of anything, oh sorry, will do you in, correct? So 1,200 shot glasses all sitting there. Now hydrogen sulfide is more dangerous. Wastewater people, biggest killer of wastewater, hydrogen sulfide. Organic decay, caca, feces. That's the world you live in. 35 parts per million carbon monoxide, slightly lighter than air. It's going to rise in this room. Hydrogen sulfide, vapor density of 1.2. We're going to find it down at the bottom. When we're walking through the sludge, where's that hydrogen sulfide? Right down by our feet. We're kicking it up. Its PEL is 10, so 10 shot glasses will make us sick. 400 parts per million, 400 shot glasses will kill us dead and fast. So much more dangerous. Wastewater, more dangerous arena. Clean water, you're traditionally not dealing. You're primarily dealing with a little bit of rust. Your spaces are a lot cleaner, a lot cleaner. Hydrogen sulfide, what's it smell like? Rotten eggs. One of the challenges is higher concentrations. It overcomes our sense of smell. And no disrespect to wastewater people, you guys can't smell anymore anyway. My gosh, I walk into those plants, I'm like green, and you guys are like, yeah, this is a great thing. You're pretty good. If we talk alternate entry, we're not talking lockout tagout. So when you're thinking about classifying your spaces, if one of the things that you have to do is lockout tagout, it's not an alternate entry space. If I just can lift up the lid and hop right in, or open the side and go right in, it's an alternate entry space. If I start talking isolation or lockout tagout, then it's permit required or non-permit required, depending on if there is a reasonable potential for poor air quality or not. Lockout tagout, no disrespect to water production and wastewater, you have some very bad habits that you've learned over the years. It's not uncommon for Mike on the day shift to close that valve and walk away and know that the second shift worker, oh shoot, he knows that Mike closed that valve. You see what I mean? Lockout tagout. What's the purpose of a tag? What does the tag do?
Information.
It communicates. What's the purpose of a lock? It prevents someone from turning that valve on. I give you that in many applications. Don't focus on the lock as much as you should the tag. And in fact, many of the power plants, because their boilers require as many as 180 to 200 points of isolation, they're not going to have a chain and a lock for every one of those. They use a red tag. If you as a contractor touch a red tag, and you're not supposed to, they walk you off the job site. That red tag has the same authority as a lock. So don't even think about touching. So make a process that works for you guys. Don't spend $1 billion on lockout tagout. Define the process, okay? This is a good lockout tagout. Everyone get the message? The tag says, Mike Kelly shut it down. Here's my telephone number. Here's the duration of the shutdown. And please don't physically turn it on. Big problem with the reliance on computers in many of your plants. Remember, the 6th step in effective lockout tagout is trust through verification. So activate the system to make sure that it's not shut down. We have a tendency as we get more computer literate to just rely on the computer. No one really knows if the power spikes and then unit starts back up, if its default setting is on versus off. Does that make sense? So trust through verification. And anytime you can, complete a physical lockout. These are all just examples of lockout tagout. Ventilation. Who owns a ventilator that does confined space? That is great. That is absolutely excellent. Excellent. A change in the recent industry has been that these axial ventilators, traditionally when you buy them, you have the ability now to reverse your flow. You can use it as an intake, which is traditionally you're exhausting the space, pushing good air in, displacing the bad air. You can also draw out, and a lot of that is driven by welders. A lot of that is driven by welders because when you aggressively ventilate a weld, you're off-gassing and you're really weakening that weld. So they want a slower flow and they want it pulling from the space. So this is an axial ventilator. This is an Abbott Lab firefighter that's testing at the intake. Who has a gasoline-powered ventilator? Excellent. But I'd like you to do two things. One of two choices. I'd like you to extend the intake or put an exhaust extension, because what's happening here is this Honeywell is actually discharging carbon monoxide, which is getting sucked into the intake. What the ventilation manufacturer says, good luck and play the wind. I don't think that's the best premise. So if you can, simply just extend this exhaust or extend this intake, and what you'll do is you'll find that your air will clean up. Centrifugal ventilators, this is centrifugal, comes in here, goes out at a right angle, more powerful, a little bit heavier, but a more effective ventilator as far as airflow movement. Remember bends reduce flow? Bends reduce flow. You see some of the pictures, you've got a ton of bends. For every bend, you're reducing that ventilator about 20 to 60%. So your flow, all ventilators are rated. If you see a little number on the side, it'll say free air. Like this axial ventilator is actually at 1285 cubic feet per minute with no bends. At one bend, as it's going over the edge here, it drops 40%. With two bends, it drops 60%. So bends reduce flow. You need to recognize that. What we're doing here is pushing air in, and we have a discharge portal on the other side. This is the most effective way to ventilate. This is fairly common for all of us, whether the space is a manhole or whether it's a smaller space. What's happening is we're pushing good air in. What's happening to the bad air? It's going out. The city of Milwaukee, one of their sewer workers, actually we trained him about 10 years ago, unfortunately fell to his death. He did a lot of right things. He tested air quality. They were in a heavy industrial area, about a 40-foot deep sewer, nasty. They opened it up, they tested air, they found it had poor air quality. They set up the ventilator. Many sewer workers, especially in the big cities, when they can't see flow, they'll spit, and they'll see where their spit will move. That tells them upstream and downstream. You've seen that before? He's ventilating, good air is going in, he's standing over the hole, bad air is going where? Right up into his face, causing him to be unconscious. He fell 40 feet head first to his death. But think about all the things he did right. If he'd just gone back, sat on the bumper, had a cigarette, I'm not advocating smoking. Sorry. But if you just give him a chance and let the ventilator do its job, he'd be alive today. That's a small mistake. He did a lot of right things. I mean, 20 years ago, prior to that, heck, they would pop that cover, down he goes. Okay, I'm the canary today, down you go. When we do negative pressure ventilation, we have to recognize that our intake is not the intake at the ventilator, but rather it's the portal. It's the portal. We had a space we were doing some work on. We were doing negative pressure ventilation. We had the ventilator up on top, and we had one of our guys in the space with a welder, and they're doing negative pressure ventilation. Well, the welder needed to take a break. He goes through, pretty big guy. He got stuck in the portal for the entry, which happens to be what? The intake for ventilation. Well, my rescuer's in there, and the monitor starts going along, alarming, because we're simply pulling out all breathable air. So you got to really think about what you're doing when you change ventilation. So if you call it alternate entry, 5 steps. Permit, barricade, test, monitor, continuous ventilation. I believe that they made me king in 1993 and said, hey, Mike Kelly, what do you think? I would add 2 things. I would add a harness all the time to anybody that goes into an alternate entry, because I'm a rescuer and I know I have to do that. And 2, I would establish a process of notification. Because if I go out and I'm doing dry well testing and I'm doing 20 of them or even 10 in a day, and in the first one at 7:30 I have a heart attack, you're really not going to know that I'm missing until 3:30 at the end of the day. So I like, hey, I'm going into this space, calling dispatch, calling fire, calling police, calling supervisor, and I'm going to be in for 30 minutes, and at 35 minutes someone comes looking for me. Permit required, I have to tell you, in my eyes, this is the way you need to do it. 8 steps vertical. Permit. Isolate if possible. Attendant. Test air, monitor air. Every entrant, full body harness. If it's vertical, greater than 5 feet, that is the only criteria at all in the standard with depth. It says vertical, permit required, greater than 5 feet, a mechanical advantage system is required. Set up your ventilator. Now when you look at the standard, it really doesn't say set up the ventilator, but it says you must have a rescue plan. And part of our rescue plan is going to be 911, vent and retrieve. Therefore, you can't go, excuse me, sir, could you run back to the shop and see if that old ventilator is got fuel in it and hasn't turned the kerosene and varnish and it's going to work. So having that on the job site makes all the difference in the world. Profile. Understand, harnesses have changed quite a bit. And profile is going to be really important. If your harness is too loose, your head-to-butt profile is going to be too wide, therefore George can't retrieve me. So it's got to fit properly, and it's got to be able to reduce my profile effectively. Some devices they use a spreader bar. Spreader bar attaches, keeps me a little bit more straight. I'm 4 foot nothing, so you add another foot to me or 2 feet, it's still not a problem. But if you're a 6 footer or 6'2", you add a little bit more height, that can be problematic. Harnesses today are really focused at profile and comfort because they really don't want that suspension trauma to occur on your legs, that lactic acid to build up. And then you save me, but literally I die of a heart attack because now all that bad poison, that lactic acid is released. I was talking to someone yesterday, one of the sewer workers. This is a great idea. This is Sheboygan, Wisconsin. They got tired of taking the tripod and the winch every time, this big bulky thing. So their Vector trucks, they built that. So they drive it up to the sewer, They pull the pins, swing it out. They have a rope system. They hang it up there. The only change that I made was I had them build a small little aluminum box in the cab. And they took the keys out of the ignition, they put it into the little box, closed the lock, and gave it to the entrant. What did we do? Lockout, tag out. Because driving away with me attached to the rope is a bad start to the day. But is this easier one? I mean, be creative. Be creative. Make it easy for yourselves. If you need an anchor point, don't grab a tripod, shoot. Create an anchor point. You're great at building and fixing things. Just look at it. At fire department responders, you want a hand in that anchor point creation, because what you don't want out of the fire department is, oh, you know, shoot, you got that pink attachment there. We're not going to use that because we don't like pink, but if it was red, yeah, we do the red one, yeah. So you want that by, because we're like that, aren't we? Yeah, we're not going to use that. Nah, you know. Davits. Many of your locations have davits for pulling pumps. Don't use the winch that you would use to pull a pump, but that's a great anchor point. Make it easy. It's there. The engineer or the architect cared more about the pump than they did about your personal safety when they designed these, by the way. You know, use those devices for your benefit. Don't disrespect any engineers in the audience. Sometimes you just can't fabricate an anchor point, so you're going to have to be creative. The harness may be the only thing. We're going to grab them by the harness and pull them out. That's not really technical rescue, that's brute rescue. Just brute, make it happen. Horizontals. Many of you have horizontals. 7 steps. Permanent, isolate, attendant, test, monitor. Every entrant full body harness attached to a lifeline. My contention is to you, if that lifeline causes entanglement hazards, OSHA says don't use it. Because if my entrant is over all these pipes, it's not like I can stand and pull on the lifeline and magically he's going to scoot along like a snake. And I know where he is. It's not like I'm looking for the fish. I mean, I know exactly where it is. So all it does is cause problems. Still a harness is required. You fire guys, you okay with that? Because you're not going to use it. I mean, it's not like you magically pull them out over those. It would hurt. Make sure that in your policy you have all roles defined, entry, supervisor, attendant. I'm not going to go through each one of these, but I wanted to hit contractor responsibilities. Understand, if you use a contractor, you must share history, classification, and hazards of the space. And you can do that by creating a confined space inventory. That inventory will really be a guide for you. In fact, we have some handouts. You're welcome to look at them as an example. A picture is worth 1,000 words. We've created a document that takes a picture, defines the hazards of the space. If you have that, you simply hand that off to the contractor. And you've met your criteria. Turnkey. Beautiful. At the end, you've got to debrief us. Because we might have found something out about the space that you didn't know, or we've modified it in some way. So that's important, so debrief. When we talk rescue, understand the largest number of fatalities occur in would-be rescuers, yes? The challenge for you, especially with having your emergency response people as part of your workforce, is you've got a deep, deep bond with your coworker. It's very difficult for you to be totally objective when your best friend is dying in that confined space. So you have to recognize, here's the solution. Set up the entry so that you're going to be successful. If you believe you have a reasonable potential for poorer quality, make sure you've got effective ventilation. Make sure that you have one of the emergency responders, maybe in a breathing apparatus, standing by in case they need to go in and do that work. Our goal is to complete in any rescue. As an attendant, all of your people need to know they are part of the rescue quotient. That is, they're going to retrieve, they're going to ventilate, and they're going to call for help. So every one of your attendants, if you ask them on the next job, are you a rescuer? Their answer should be yes. Yes. They need to know their job. Yes. You are a don't even think about it, go in rescuer. But you are a rescue. Because once we get into rescue, we really have to categorize these rescues. If you read this document, it's part of the handouts that we have, it's a rescue matrix. If you look on the far left-hand side, it's don't go in, just retrieve them. The one in the middle is probably what you're going to encounter most often. Good air quality, medical emergency on the part of the entrant. And fire department, don't get stuck focusing on that infrequent, high risk, poor air quality, because if you're doing your job correctly, you're managing air quality. That shouldn't go bad. The tendency is for emergency responders to jump to that worst case scenario. So really practice those things that allow you to set up a technical rescue plan that you can effectively get the worker out of the spaces. This is a device called a SCAD. Who's a deer hunter in this group? Deer hunter actually created this fabulous device. If you take a Stokes basket that you normally see on the side of the apparatus, it's 24 inches wide. Guess what? It's not fitting in most of your confined spaces. So this device actually goes, keeps you aligned, and was started out as a deer drag, but it totally conforms to your body. So it keeps you nice and rigid, great stabilization, and conforms to you. So you can get them right out of the space. Those are devices that technical rescue teams should have. And by the way, all of you have county response of technical rescue teams, correct? Which is really good. Yes? Say yes? Yes? That's great. That's the good news. The bad news is they're 45 to 65 minutes away. Shoot, I'm having a heart attack in a good air quality space. 45 to 65 minutes is a heck of a long time for me to wait. So what do? Rescuers, we go in. We go in. Yes, sir. Gotcha. In the handouts that we have, we also have what OSHA called Appendix F. F actually is the document by which emergency responders should be evaluated. Capabilities and performance. It's a document that asks questions of what should be expected of you. So, any questions at all?
I got a question.
Yes, please.
You're a contractor, and I don't follow the procedures you just talked about.
Great question. Great question. Here, the question is, what happens if I have a contractor that does not follow their policies or OSHA or Minnesota policies? Here's my answer. First of all, go to your legal representatives, and when you sign that contract with me, the contractor, not only say that I must follow all applicable standards, but also say what the remedy is. What are you going to do if I don't? Call OSHA. Shut me down. Warn me. Fine me. Whatever you're going to do. So establish that up front. And then when you, during the normal course of your work, find that the contractor is not doing their job, follow whatever process you've established. What I'm saying is you should not be enforcement inspectors. You should not be standing over, looking over my shoulder going, did you calibrate that monitor? But at the same time, if you see me go into a permit-required confined space, pop the cover, jump right in, every one of you know that that's wrong, correct? Therefore, I mean, you're walking by delivering some materials to another part of the facility, and you see that. I believe you have a responsibility both morally and ethically and from a compliance standpoint to communicate to someone. My rule is, as a worker, always throw that football higher up in the food chain, yes? Call that foreman, have that foreman, if they have a good process, they call their boss, and then deal with it. But you do not have the responsibility of enforcement. Make sense? Great question. Anything else? Either I did a really good job or I bored you to tears.